There's antimony, arsenic, aluminum, selenium, and hydrogen and oxygen and nitrogen and rhenium, and nickel, neodymium, neptunium, germanium, and iron, americium.
Good morning, class. Welcome to chemistry class. I'm Mr. Gerould, and this is my assistant. Yay! Today we will cover the introduction to chemistry. First is Democritus. Everything is made of matter, and within matter, Democritus believed that tiny individual particles called atomos existed. He was the first person to propose the idea that matter was not infinitely divisible. He believed that atoms could not be created, destroyed, or further divided.
Neodymium, neptunium, germanium, and iron, americium, ruthenium, uranium, europium, zirconium, lutetium, vanadium, and lanthanum, and osmium, and astatine, and radium, and gold, protactinium, and indium, and gallium, and iodine, and thorium, and thulium, and thallium.
Democritus's ideas do not agree with modern atomic theory. His belief in the existence of atoms was amazingly ahead of his time. However, his ideas were met with criticism from other philosophers, such as, what holds the atoms together? Then came Aristotle with his criticism.
And iodine, and thorium, and thulium, and thallium. There's yttrium, ytterbium, actinium, rubidium, and boron, gadolinium, niobium, iridium, and strontium.
The concept of the atom was revived in the 18th century when John Dalton, an English school teacher, revived and revised Democritus's ideas based upon the results of scientific research he had conducted.
There's yttrium, ytterbium, actinium, rubidium, and boron, gadolinium, niobium, iridium, and strontium, and silicon, and silver, and samarium, and bismuth, bromine, lithium, beryllium, and barium.
The cathode ray. Multiple experiments helped determine the properties of cathode rays. Scientists continued their research using cathode ray tubes, and by the end of the 1800s, they were fairly convinced by the following. Cathode rays were actually a stream of charged particles. The particles carried a negative charge. The exact value of the negative charge was not known, however. Because of the changing type of electrode in the varying gas at a very slow pressure, and the cathode ray tube did not affect the cathode ray product, it was concluded that the ray's negative particles were found in all forms of matter. These negatively charged particles that are part of the forms of matter are now called electrons.
There's holmium, and helium, and hafnium, and erbium, and phosphorus, and francium, and fluorine, and terbium, and manganese, and mercurium, molybdenum, magnesium, dysprosium, and scandium, and cerium, and cesium.
By 1920, Rutherford had refined the concept of the nucleus. He concluded that the nucleus contained positively charged particles called protons, which are subatomic particles carrying a charge equal to but opposite that of an electron. The neutron was shown by Rutherford's co-worker that the nucleus also contained another subatomic particle, a neutral particle called the neutron. A neutron has a mass nearly equal to that of a proton, but it carries no electrical charge.
Fluorine and terbium, and manganese, and mercurium, molybdenum, magnesium, dysprosium, and scandium, and cerium, and cesium, and lead, praseodymium, and platinum, plutonium, palladium, promethium, potassium, polonium, and tantalum, technetium, titanium, tellurium, and cadmium, and calcium, and chromium, and curium.
Okay, now on to scientific notation. Scientific notations are just a unit of measurement. Scientific notation expresses numbers as a multiple of two factors, a number between 1 and 10 raised to a power of a power or exponent. Remember that the exponents tell you how many times the first factor must be multiplied by 10.
And cadmium, and calcium, and chromium, and curium. There's sulfur, californium, and fermium, berkelium, and also mendelevium, einsteinium, nobelium, and argon, krypton, neon, radon, xenon, zinc, and rhodium, and chlorine, carbon, cobalt, copper, tungsten, tin, and sodium.
Okay, on to the next. I'm going to show you how to multiply and divide with scientific notation. In the first example, it is multiplying. In the first step, you multiply the first factors. which is 2 and 3. So in the second step, you'd multiply 2 and 3, which makes 6. And after that, you'd add the exponents, which is 3 and 2, which equals to 5, and your answer would just be 6 times 10 to the 5th power. So in the end, all you do is just break it down and put it together in the end.
These are the only ones of which the news has come to Harvard. And there may be many others, but they haven't been discovered.
Scientists indicate the precision of measurements by the number of digits they report. A value of 3.52 grams is more precise than the value of 3.5 grams. The digits that are reported are called significant figures. Significant figures include all known digits plus one estimated digit. Rules for recognizing significant figures. Number 1, non-zero numbers are always significant. Number 2, zeros between non-zero numbers are always significant. Number 3, all final zeros to the right of the decimal place are significant. Number 4, zeros that act as placeholders are not significant. Convert quantities to scientific notation to remove the placeholder zeros. Number 5, counting numbers and defined constants have an infinite number of significant figures. And that's it. Class is over. Bye!